Okay, so today we are going to learn how to identify oxidized and reduced species and agents. Okay, so let us start with the oxidized and reduced species, and we will move from there. Okay, so this is the question that we had from last time. How to identify if a reaction is a redox reaction. Today I'm going to show you how to answer that question. Okay, so I had to grab my examples here because the other kinds of reactions are easy for me to like make up on my off the top of my head, but these are a little more complicated. So I need to go to the examples. Okay, so I'm going to give you this chemical reaction. I want you to write this down in your notes.
On a sheet or
On your notes, I think.
Alright.
I mixed up and I made a mistake here at the beginning. So if you put I minus, that's because I did wrong. It's really I2. Okay, so whenever you're asked to identify anything like the oxidized or reduced species, you have to identify oxidation numbers for every single substance in every single compound. So that's what we need to do now. So take your red sheet out. Hopefully you did some of your homework, page 1, so that you are able to be competent at doing these things. All right, so if there's only one of a compound, or one of an element, sorry, in a compound, what is its oxidation number? 0. Rule number 1. Okay, what is the oxidation number of oxygen here? 100?
-2.
Thank you. Okay, so how do we figure out what chlorine is? Well, you could look at your periodic table and it'll tell you that there's a whole bunch of different possibilities, but we're going to need to use our little math formula to help us. So chlorine, there's one of it. There are 3 oxygens. And what do all of these oxidation numbers need to add up to? -1. Good job. You're back.
I think it's at 10.
Oh, it says at 9. It said at
I know,
9:30.
and then if you read it, it says starts at 10.
But then why did they make the request for 9:30?
I don't know. That's just miscommunication on
Is
Miss Peter's part.
okay. Well, if she is looking for you, I guess she'll come find
There's
you.
no one in the room either, so it's like,
$2 times 3. Yeah, I could win 40.
Do you want me to call down to the office?
What is it?
What do you got? Really bad odds.
if you want
What's
to.
your
Okay. So, did we figure out what chlorine was? So chlorine has to be +5. Okay, good. But we need to keep filling it out for all of the rest of them. What is oxygen? And what is chlorine here? Good. What about this friend? Not 0. -1. The reason it's not 0, there is only one of it, but this number, or like this charge, is not 0. So that's how I know that it has to be -1. That is, I think, rule number 4, the monatomic ions. Is that the one? Okay, so now we've identified all of our oxidation numbers. This is the tricky part. We have to decide who has an oxidation number that is changing. Okay, so it looks to me like it can't be oxygen because oxygen is a -2 before the reaction and it stays -2, and so they're not changing at all. But there are 2 that are changing. I see that chlorine is going from +5 to +7. And I see see that not oxygen, iodine is going from 0 to -1. One of these two is getting oxidized and the other is being reduced. So we have to decide what that is. Okay, so I'm going to write on the board here a little review. That'll be confusing if I do that. Oxidation is, do you remember from last time? Something of electrons. Loss of electrons. And reduction is gain of electrons. There is a really nice little mnemonic device. Do you know what that is? It's like a little memory trick to help you to remember these things. It's as cringy as you can imagine, but it's effective. So here's the little thing that you can try to remember. Leo goes grr. Like Leo the lion goes grr. Don't try to make a racist joke, Joe. It just once you catch up to me, you'll see what I mean. So Leo, what does that mean? Lose electrons, oxidize. What does grr mean? Gain electrons, reduce. So if you can remember this, or maybe write it down on your red sheet, that'll help you. Okay, so we need to figure out who of these things, it'll either be iodine or chlorine. Somebody lost electrons and somebody gained electrons. But it's not as simple as it seems.
Is a reduction.
Yes, Mason?
Those,
Okay, just hang on. It's not as simple as it seems because when you gain electrons, your number does not become more positive. Your number becomes more negative. So whenever you're trying to figure out who is reduced, your oxidation number, you're looking for the one that gets more negative. And when you're looking for oxidation, you're looking for the oxidation number that gets more positive. In the opposite way that, like, if you make money, if it's payday from your job, you've made money, you've gained money, it comes into your account as plus. So you have more money. It looks like you have more. It doesn't look like that when you have more electrons. Mason?
Then your crippling student debt number gets smaller.
Yes, that would be true. Yes, that would be true. All right, so let's look at what's happening. In the case of iodine, I'm going from 0 to -1. Is that number getting more negative or more positive? More negative. So then iodine is the reduced species. And so then that means by process of elimination, because there are only 2 of them, chlorine must have been oxidized. But let's make sure that that's true. Is this number getting more positive, +5 to +7? It is. So then that's my oxidized species. So these are your steps to complete this task. Identify all the oxidation numbers. Look to see which elements have changed their oxidation numbers. And then figure out who gains and who loses electrons. Okay, let's do another example. This is my next reaction. Go through and identify all of the, identify all the oxidation numbers.
do we have a sheet on this?
It's your red sheet.
Is this number?
Well, you have to decide. There's a couple of number 1s and a couple of number 4s. But this one's a pretty easy one. There's no figuring that's necessary. You can see them all just by looking at them. So what's the oxidation number of this guy?
2 plus.
Plus 2. Minus 1. What about this Br2?
Zero.
0. That's a rule number 1. And what about this cobalt here? Oh, that's an O. Also 0. Okay, so now we need to figure out which things have changed. Well, there's only 4 substances, so in this reaction, so I'm going to draw my line between them. The cobalt goes from plus 2, sorry about that, from plus 2 to 0. And the bromine goes from minus 1 to 0. Okay, so now I'm going to start by making a little table like this, where I'm just abbreviating the words oxidized species as OS and reduced species as RS, so I don't have to write all those words out every time. So I want to identify my oxidized species. Remember from earlier that if something is oxidized, it's going to be getting, its numbers will be getting more positive. So if I want to first identify the oxidized species, which one of these things gets more positive? Joe? The Br. So Br is my oxidized species. What about my reduced species then? Good. Now, if you look back, so obviously it has to be that because it's process of elimination, but if you look back at this, does this number get more negative? Is that true? It is, because plus 2 to 0 is getting more negative. How are we doing so far? Is this okay? Okay, let me do another example.
Oh, is that all we have to do?
There's one other thing that you have to do, and it's not hard, but it's
Are you
tricky.
working on homework today?
Yeah, for most of the rest of the class.
Oh, wow.
Like I said last time, I think you should be able to finish this homework today with the class time that I give you, if you can lock in.
All the homework?
Yes.
3/4 of it done then?
Maybe I'll finish this page.
Okay, so what's our first step? What do we need to do?
Do the
Numbers.
The numbers. Yep. Okay, so go ahead and do that.
Oh,
For every single element in every single species, in every compound.
it's funny.
There's a guy in aggregate.
Is that
too, like,
Did you see anybody get kicked out? Or like have to get escorted out by
I
the
saw a
security?
police officer almost he got capped by a car. There's a drunk guy and he was walking across the street when the police had everyone stop. And he's like, hey, what are you doing? And the guy was like super drunk. He was nonverbal. It was funny. And then the police go over him and he pushes him across the street the rest of the way. Without looking, he turns back around and the car slams on his brakes and kind of hits him.
Oh dang.
Yeah, it's fun.
Oh dang.
Honestly, I would have stopped.
You just gotta get out of it.
You gotta try not to be in like GTA mode if you're in that kind of setting. Okay, so now here we get something a little bit more complicated again.
Yeah.
What should be though hydrogen's oxidation number?
+1. +1.
Plus 1. Yep, so we can figure out nitrogen.
Wait, what the fuck? Where did we get H from?
Right there, Joe.
That letter's an H.
It's always +1.
It's always plus 1.
Wait, what
Yes.
about that N2?
No, but where did we get that H
What's
from?
that N2 telling us?
I only see it.
Wait, no, that's 0.
Maybe you want to. Do you want to sit closer, Joe? Do you want me to make it? Want me to zoom in?
No.
Shoot, I don't know where it went.
Joe, do you need glasses?
No, sweet.
There, is that okay?
Yeah, zoom up, but where? There's no H on the other side of the equation.
You don't need it?
Oh, yeah. Don't worry about that.
What? The fuck?
Yeah, these equations are a little bit funky.
That's
Yes, I hadn't even noticed that. No, you don't need it. It's fine. It's fine. You don't need it. So obviously hydrogen is not going to be one of your reduced or oxidized species. Okay, but what does this need to add up to? Okay, so 2n is equal to minus 4. So what does 1n equal? Minus 2.
Why is it plus 1? Why do we need to equal to plus 1?
Because there's that plus here in the compound.
Oh,
And then what is the oxidation number here of this mercury? Plus 2, good.
each G is mercury.
Okay, so find the two that change. So n must be one of them, right? And it's going from 0 to minus 2. And then the other is Hg, which goes from 0 to plus 2. Okay, so if you make your little chart, always start with the oxidized species.
That's
HG.
HG.
Hg. Correct. This is the one that gets more positive. Good job. And then the other one is N.
What, Elliot?
All right, so now we're going to make things a little bit more complicated. I want you to go in your notes back to the very first example that I gave you. Okay, but as we're going through on the board, I want you to notice something. What do you notice in common about all of these things that I wrote down? The N, the Hg, CO, Br, I, and Cl. What do you notice about those? They're all
something.
They're all alone. Yes, they're just elements. They're just the elemental symbols. That's it. So that's going to be important for later. Now, I'm going to erase this here because I did not put this in the proper order. So I'm going to redo this. The oxidized species and the reduced species. The one that gets more positive is chlorine, and the one that gets more negative is iodine. So now the last thing that I need to teach you so that you can do your homework is about what we call reducing and oxidizing agents. So what is a reducing agent? It's something that allows something else to be reduced. Okay, so I'm going to write this on the board, and then hopefully I won't lose you because this is a little bit tricky. So a reducing agent is a substance, a compound. You should write it down somewhere. That allows something else to be reduced. The reducing agent is a compound that allows something else to be reduced. It's something that allows reduction to take place. So if you're a reducing agent, what do you have to do? You have to be the one that loses. So the reducing agent is a compound that must contain the oxidized species. Because what do you do when you're reduced? In order for something to be reduced, it has to gain electrons. So the substance that allows reduction to take place is the thing that produces those electrons that can be gained. In order to produce electrons, you have to be oxidized. Oh, are you okay?
Yep.
So, what you're going to have to remember is that when you're writing your list of things for your homework, so on pages 2 and 3 of your homework, I'm going to ask you to identify the oxidized species and the reduced species. the oxidizing agent and the reducing agent. So this is what's important to remember. The first two things in the list will always only ever be elements. In the same way that we just did that on all of these example problems. The agents will be compounds, but not just any kind of compounds, they will be reactants. If you put a product as an oxidizing or a reducing agent, that's wrong, because in the product's side of the reaction's already taken place. You need something that at the beginning is going to be an ingredient that allows reduction to take place. Now, the oxidizing agent is exactly the opposite. I just am not going to write that down because I don't want to confuse you anymore. But you can figure out what the reducing agent is. The other thing is the oxidizing agent because it's always opposite. Okay, so then let's go back to these examples that we had before and identify the oxidizing agent and the reducing agent. Okay, so I'm going to follow my instructions on the board. It says the reducing agent must contain the oxidized species. So no problem. I'm going to find my oxidized species, it's Cl, and I'm going to go to the reactant side of my reaction, and I'm going to find that compound and write that down here. ClO3 minus. This must have a charge. It has a charge here. And so it must also have a charge in your list because it doesn't make sense if it doesn't have the charge. It's a nonsensical compound.
Why do you do the...
Let me explain that again. So in order to find the reducing agent, it needs to contain the oxidized species. So I went up and I found what I determined was the thing that got oxidized. So I found my OS, that's Cl. And now I'm just going to go to the left side of my reaction and find the compound that has chlorine in it.
Oh,
And just copy that down.
so the left side?
The left side, yep. Not the right side. Don't ever look on the right side because that's when the reaction's already taken place. Those are your end products, not your ingredients. Mason?
Do we write like the coefficient in front?
No, not the coefficient, just the compound name. Thank you for asking that. So then what's the oxidizing agent? Well, we'll do the exact same thing, only opposite. So this one will find the reduced species, the I, and we'll just go back to the left side, and what was the compound that the I came from? IG. Okay, so now let's go down to the next example that we did earlier and make the rest of our table. We need the oxidizing agent and the reducing agent. So I like to find the reducing agent first. I'm going to find who did I determine as my oxidized species? Oh, well, I said bromine. So now I'm just going to go to the left side of my chemical equation and write down whatever compound I see that had bromine in it. And so this one is Br minus. Make sure that the minus goes with, because Br plain is something totally different.
Yeah, man.
Okay, for the oxidizing agent, you're going to do the opposite, but in the same way. So go and find cobalt, and what is its left-hand side of the equation thing? CO2 plus. How was that? Easy, good. Let's do the last one. All right, so we need oxidizing agent and reducing agent. Okay, so to find the reducing agent, I'm going to find the oxidized species. I'm going to look on the left-hand side of the equation, and here it says 2Hg. I don't want to write the 2. I just want to write the Hg.
Why not?
Because I don't need to. I don't need to write the 2, so why do it?
Joe, I was just making sure.
I make you do enough nonsensical things, so don't do it if you don't have to. If you do write the 2 down, I won't mark it wrong. Elliot? Oh, you just were stretching? Okay. What's the oxidizing agent though here? N2.
Yeah.
N2. Okay, so now just look at this. Sometimes the species and the agent are the same thing. But that's just a coincidence. That's not like normally true. That's just a coincidence. All right, how about we do one from your homework so that you at least have a starting point for this? So on page 2, let's do number 2.
Oh, this is like a lot of it.
Oh, number 1.
Oh,
Yeah, there's 11 of them.
There's 11 of doing that. What you did.
Yep. I don't think it'll take you real long though.
Alright, how do we do this again?
Okay, what's the first thing that you need to do?
Do the
The number.
numbers.
You gotta do all the little numbers.
What is the S and the G?
Solid, gas.
Oh.
Don't worry about that.
You need-
I sometimes can't help myself when I type and I just include them. But it's okay. If they're not there, it's okay too. Oh, they're always there. To me, the compounds look naked without them. All right, so what do we have here for the Na?
1 plus.
0.
What the fuck?
Hey, language.
Go.
Hunter, my guy, you got to pay your debt by the end of the day today.
Okay.
Okay.
Cash up you? Because my Christmas money is going into the rims. So.
Okay, sure, yes, you can cash at me. I'll pay your debt.
Alright.
I'll pay your debt in cash today. All right, Cl2, what is its oxidation number?
0.
Good. Okay, now, chlorine has a whole bunch of them, but sodium only has 1, right? So this one is +1, and what is then chlorine?
I did order $25. I was thinking about making it $35 just so I could get the record. You did have a costly day. And that was all in one class period too. In a jet block, I think, right? No, that was Schweigel.
No, that you only got $10 for that. I think when you got your your 25, that was just from a random jet block. Yes, right.
So you're ignoring the 2 in front of NA?
I am, yep. Yep.
Right, are you being a smarty pants up there?
Yeah, I am.
Why did
I'm super smart.
one for the
Because in order to balance out this compound, that's why I drew that.
Oh, is that how that works?
Yep.
My brain just shut
There you go.
Okay, so now I'm going to find the 2 things that change their oxidation numbers. And now I'm going to make my little list of all the things. OS, RS, OA, RA. You need to do this for all of the problems. Keep them in that order because it'll be easier for me to grade. And I'll get less cranky. I nearly killed somebody's hopes and dreams in AP Physics because I got cranky when I graded the last page of their final exam. So it's a thing. It's a thing. Don't make me cranky. All right, so who's the oxidized species? That is the person whose number gets more, the oxidized species gets more positive. So who got more positive? All right, so then if you want to do the oxidizing agent, or sorry, the reducing agent right away, you can. It would just be Na. So then who's the reduced species?
CL.
Cl. And remember, the species, these 2 first lines are always just going to be one element. So Cl2 then would go on the 3rd line.
Oh, that makes no sense.
Yes, Hunter?
So they mix together, they make like +1 and -1 because it's a compound.
Mm-hmm.
Alright.
Correct. Correct. Do you want me to do another one? Yes, Mason?
I was just saying, I don't know why I'm really stuck at
Number
number 2.
2? Okay, let's do that one. All right, you try to identify the oxidation numbers while I,
How do we find those numbers?
using your red sheet or your periodic table.
Hydrogen is right. Hydrogen is always +1.
In a compound, yes. Yep, that's true. So this would be +1, and here this would be +1. Did I tell you that any were peroxides?
No.
Yeah.
No, so the oxygens will always be good. Okay, so then what about K? What about K on the left? The K on the left is 0,
+1.
and +1 it is on the right. Good.
That makes sense though.
And what is the H2 oxidation number? Mhm. Okay, so then find the two that change. Did you call the first potassium
Wait,
+1?
there's a +1 and a 0 for H.
Ah, indeed. Okay, so
Oh my god.
choose the one that changed, not the one that stayed the same. Okay, so here my number goes from +1 to 0. And here my number goes from 0 to +1.
Then doesn't oxygen stay the same? So
It does, so it's not one of the, it won't be on our list. Okay, the oxidized species is the thing that gets more positive. So which thing does that?
Okay.
Okay. Oh yeah, I had my music is on still. I don't like silence.
Dr. Schweigel randomly started playing music there the last week before.
What Dr. Schweigel did?
It just would play.
What was he playing? Gregorian chant?
Yeah, and then it would stop, and then it would play randomly again.
I can't see him blasting tunes.
It was weird.
Okay, so then my reduced species is the thing that gets more negative. So who is the reduced species? Good. Remember, those two are just elements, so only one elemental symbol here. The reducing agent is also just K, so my first and my fourth lines are the same. What's the oxidizing agent? H2O. It has to be a reactant. You can't look at the product side. Okay, so you have the rest of the class, and that's over a half an hour to work on this. I expect that you should be able to make a pretty good dent in this. Please get your work checked. These are, like, if you mess up a little bit of an oxidation number, you'll screw your whole problem up. So don't worry about that so much, but get them checked. Now, I didn't talk about this because I was kind of waiting until everybody was here, but now everybody's not here again today. So I'll just have to say it early and often, I guess. I'm going to be a lot more strict this semester with your late work. So if you hand in a work that's due at the beginning of class, at the end of class, I will mark it late, because it is. So really be careful about that. Also, I'm still happy to check your work, but I will only check it one time. So if you get your work checked and you've got, let's say on your first page you had 5 errors, you have to fix them on your own. I've already told you that what you originally had was wrong. I'm not going to look at it again. So that is just to help you to become less dependent on me. You can do it. You don't need me. You can, but I'm happy to tell you the first time that, yes, this is not quite right, because it's good to learn from your mistakes. But I want you to try to be less dependent on me and more reliant on your own abilities, because you're all smart. You are all smart. So that's just my little PSA for the day.